Hey there, and welcome to today's Explainer. Get ready to look at your midday meal in a completely new light. Today, we're unpacking the anatomy of a supermarket lunchbox. We're going to explore all the hidden science and, just frankly, astonishing food engineering that goes into our everyday food. Seriously, take a second and think about it. Have you ever wondered why that pre-packaged supermarket sandwich sitting in your bag right now isn't just a soggy mess by lunchtime? Or why your trusty microwave meal somehow manages to have molten lava edges but is ice cold right in the middle? Our go-to meal deals might seem incredibly simple, but they are actually marvels of hidden scientific engineering. Okay, let's dive into this. Here is our meal deal menu for today's Explainer. First, we'll uncover the science of the sandwich. Second, we'll decode the truth behind those so-called healthy snacks. Third, we'll master the secrets of the microwave. Fourth, we'll explore the magic of canned food. And finally, we're going to solve the great chocolate chip mystery. All right, kicking things off with Section 1, the science of the sandwich, mayo, and the perfect bread. So why on earth do 85% of supermarket sandwiches use mayonnaise instead of, say, butter or another spread? It's a staggering number, right? In a survey of supermarket shelves, out of 46 sandwiches at one major store, 39 relied on mayonnaise. At another, it was 29 out of 36. Sure, mayo is a fantastic carrier for flavor, so seasonings can be spread from corner to corner consistently. But the real reason it's the undisputed champion of the sandwich aisle comes down to one thing: structural integrity. Well, the secret weapon inside mayonnaise is an ingredient called lecithin. Lecithin is a fat enzyme found naturally in eggs, and its superpower? It creates an emulsion. This basically means it wraps around water and binds it securely to oil. You know, two things that naturally want to stay far apart. When this emulsion is spread across your sandwich bread, it creates a waterproof barrier. This barrier is absolutely crucial because it stops wet ingredients, like sliced tomatoes, from leaching all their juices into the bread and turning it into a total soggy disaster before you even reach the checkout till. And honestly, this brilliantly illustrates why mayonnaise can sometimes go horribly wrong. Have you ever put a mayonnaise sandwich in a toasty maker? Total disaster. Heat actively breaks down that lecithin bond. When that emulsion shatters, the oil and water go their separate ways, leaving you with a greasy, separated mess that instantly ruins the bread. Now, what about the bread itself? If you compare soft bread rolls to crusty bread rolls, you might assume they're essentially made of the exact same stuff. Actually, scratch that assumption. To achieve that pillowy texture in a soft roll, bakers add a significant lump of vegetable shortening, or fat, and up to 12% sugar, compared to just 0.5% of sugar in a crusty roll. This extra fat and sugar acts as a preservative, stopping the dough from drying out in the oven and vastly extending the roll's shelf life. So how exactly do you get a crusty roll without all that fat? The secret is surprisingly counterintuitive. After the dough is mixed and the gas is knocked out of it, bakers introduce steam at the very beginning of the baking process. Now, you'd think adding moisture would make the bread softer, right? But the exact opposite happens. The steam condenses on the cold dough and the starches absorb that moisture to create a gel. As the oven heats up, that starchy gel crisps up, creating that perfectly crackly, hardened crust we all love. Moving right along to Section 2, the truth behind healthy snacks, decoding the crisp aisle. Now, what's really interesting here is how our assumptions about healthy snacks can totally lead us astray. Just think about virtually identical serving sizes across different snacks. A bag of traditional sweet chili potato crisps sits at 197 calories. Meanwhile, those saintly-sounding quinoa corn puffs pack 227 calories and actually contain 5 grams more fat. And if you reach for sweet potato veggie sticks, thinking they're the ultimate diet hack, well, be warned. They contain a massive 10 grams more sugar than a standard bag of cheap, retro cheesy curls, which only come in at 184 calories. But get this. Perhaps the most shocking revelation about those high-calorie quinoa puffs is this number: 6%. If you look closely at the ingredients list, those expensive quinoa puffs only contain 6% actual quinoa. Kind of wild, right? There is, however, a genuinely healthier alternative hiding in the crisp aisle: pea snaps. They boast 3 times the protein and 6 times the fiber of standard retro puffs. But how do you turn a dried yellow split pea into a light, puffy crisp? It requires a seriously high-tech extrusion process. First, the peas are milled into flour. Then, to stop them from tasting exactly like, well, mushy peas, they're passed through a highly secretive flavor-taming chamber. This tamed flour is then mixed with water in an extrusion machine under immense heat and pressure. Finally, as the mixture hits the surface, it's instantly baked and chopped in an absolute split second, creating a perfect protein-packed puff. Let's heat things up with Section 3, Secrets of the Microwave, Mastering the Hot Lunch. Listen, if you take away just one thing from this explainer, make it this golden rule. Microwaves require high water content to work properly. This is exactly why a saucy, moisture-rich chicken tikka masala thrives in a microwave, but a dry, crispy pastry or samosa turns into an absolute soggy mush. Right, so to understand why, we've got to look at the physics. Unlike a traditional oven that cooks food from the outside in using a heat source, microwaves use a device called a magnetron. This magnetron produces electromagnetic waves that bounce erratically all over the metal interior of the microwave and penetrate your food. These waves specifically target water molecules, causing them to vibrate rapidly. This incredible microscopic friction is what actually generates the heat. But because wave interference is so chaotic, it creates distinct hot and cold spots throughout your meal, which, by the way, is exactly why the instructions always demand that you stop and stir your food halfway through. But, science isn't just about how you heat the food, it's also about how you perceive it. In a fascinating sensory experiment, scientists tested sonic seasoning and presentation. They took an ultra-cheap 69-pence microwave lasagna and fed it to two groups. The first group ate it straight from a plastic tray in a plain room and valued the meal at just a few pounds. The second group ate the exact same 69-pence lasagna, but were given heavy, expensive cutlery, served on nice china, and listened to classical music. The result? The second group valued the exact same cheap meal almost 28 pounds higher. The weight of your cutlery literally tricks your brain into thinking the food is higher quality. Let's move to and see how this builds in Section 4, The Magic of Canned Food, the Ultimate Shelf Life. Cans are basically designed to be impenetrable fortresses for our food, but getting them there is an extreme journey. First, our recycled scrap cans are thrown into a furnace and melted into liquid iron at a scorching 1,700 degrees Celsius. Next, this liquid is blasted with oxygen at twice the speed of sound to reduce the carbon, creating a highly malleable, super strong black plate steel. But steel has one fatal flaw for food storage. It rusts. So to combat this creeping threat, a micro-thin lining of tin is permanently bonded to the steel plate. This perfect marriage of strong steel and rust-proof tin ensures the contents inside are entirely protected from the outside world. So just how effective is this metallic fortress? Try 50 years. 50 years! In a demonstration by a mycologist, that's an expert in molds, a perfectly intact can of kangaroo tail soup from the early 1970s was opened. Because the can was undamaged and stored properly, the soup inside was tested, deemed perfectly safe, and actually eaten 50 years after it was canned. As long as the can has no dents, bulges, or hissing pressure, the food inside can technically remain safe to eat indefinitely. Finally, let's wrap up our Lunchbox tour with Section 5, The Chocolate Chip Mystery, Defying the Oven. Have you ever actually wondered how the chocolate chips in a cookie survive the intense heat of an industrial oven without just melting entirely into the dough? Well, this quote from a master chocolatier blew my mind. All chocolate starts melting at around the same temperature range. That's right, bake-stable chocolate chips do actually melt in the oven, right around 28 to 38 degrees Celsius, just like any other chocolate. So the crucial point is that melting behavior is entirely dictated by fat content, specifically cocoa butter. A high-end, 90% dark chocolate bar contains around 50% fat. When it hits the oven, it liquefies and runs absolutely everywhere. Bake-stable chocolate chips, on the other hand, are engineered with a very low fat content. When they hit that melting point, they do melt, but they just don't have enough liquid fat to lose their structure. The cookie dough bakes around them, forming a caramelized crust that locks them in place, allowing the chip to melt and then perfectly reform its shape as the cookie cools down. And that brings us to our final thought. The next time you grab a meal deal, microwave a quick lunch, or bite into a chocolate chip cookie, take a second to appreciate the sheer amount of food science that went into the whole shebang. It makes you wonder, what other hidden marvels of engineering are sitting right now in your kitchen pantry? Stay curious, keep exploring,